Welcome to our next video for Stat 212. In this video, we're going to talk about confidence intervals for measuring relative risk. In particular, we're going to focus on interpretation of intervals rather than kind of a calculation and construction, though we will talk a little bit conceptually about what's going on here when we construct a confidence interval for relative risk. So as a reminder, if we're doing inference, which most of the time we're doing statistics, is we're starting with our sample data and trying to make some claims about what could be true in the population, what a particular parameter could reasonably be. So the same thing is true when we're measuring risk, is that we're probably going to have a sample of people, and we're trying to kind of estimate what the true relative risk or some measure is in the population based on our sample result. So commonly we're going to turn to a tool like a confidence interval to try to estimate where that parameter could reasonably be given the information that we have. Our sample statistic, so the relative risk calculations that we're typically going to be using here, so for example in this table of data right here, this is a sample. We're calculating a sample relative risk that is an estimate of the true relative risk in this context. So when we go about this, we're going to kind of follow some similar procedures as before, that we want to calculate a standard error for our sample statistic. We want to calculate how much error we should expect to have with the sample statistic as a measure of the population parameter. And then secondly, we're going to decide how many standard errors we should extend out based on our desired level of confidence. And this would kind of be like a margin of error. And then finally compute an upper and lower bound for our interval and interpret it. However, relative risk is a little bit different than a confidence interval for, say, a mean. And that's because calculating the standard error is going to be a little bit complicated. One thing that's going to take place here is that measures like relative risk are going to be on a scale from 0 to positive infinity, with 1 being kind of the center of that interval. So if you think about it this way, a value of 0.5 is basically equivalent to a value like 2. So what happens is I get this kind of very uneven interval where, being lower is not going to correspond equally to being higher. Kind of the reciprocal of those values is not an evenly moving scale. So there's some stuff going on that we're not really going to worry about, but kind of going behind the scenes is that there's what's called a log transformation of relative risk, and then a confidence interval is constructed, and then that calculation is kind of reversed, and we take the exponent of the other side. So the part that you should care about, the part that matters here, is that the confidence interval for relative risk is not going to be symmetric about the point estimate. It's actually going to be asymmetric. So there is a relative risk value that we're kind of building our interval from, but the interval is not going to be symmetric about that point. It's going to have a smaller range on the 0 side and a larger range on the positive infinity side. So that's the only thing I wanted to mention to you. We don't have to worry about calculating it other than just being aware that that's a thing, and that's going to happen when you're looking at a relative risk confidence interval. Okay. So in our class, we're going to focus on interpreting, and in a couple cases, we might use this online calculator to gather some information. So what we're going to do here is we're going to calculate the 95% confidence interval for relative risk in the case of the Salk vaccine study. So I'm going to open up this calculator here, and I'm going to plug in our information. And so I'm just going to go back to the Salk vaccine study here, and we're going to calculate the relative risk and then the interval bounds. So in this case, we had the Salk vaccine. We had 33 who got polio and 200,712 who did not. And then we also had 115 in the placebo group who had it, and 114 who did not. And I'm going to do a 95% confidence interval, so I'm going to do 0.95 in that box. And then if I calculate this out, I'm going to get some values down here. So you're going to notice that there is a point estimate. That is the relative risk value that we calculated from before, 0.288, 0.287, somewhere around there. There's also going to be a lower and upper bound of 0.195 and 0.42, let's see, 424 if we're going to round that. So 0.195, 0.424 are going to be our interval bounds. And so that calculator is doing kind of the hard work for us. It's doing the log transformation, it's calculating the standard error for us, it's doing those things and producing this result, so we can just focus on the actual mathematics. I mean, that's what we use technology for in statistics. We're not calculating everything by hand because that would be ridiculous, but we can certainly use tools well and interpret the values in context. So we're 95% confident. Oh, actually, sorry, I'm going to get ahead of myself here. So let's go ahead and interpret this interval now. And there's 3 different interpretation statements provided here. And the question here is, which of the following statements do you think would correctly interpret this interval? So I'll let you kind of take a look for a second. Maybe you want to pause the video and think about it. Which of these statements do you think is correctly interpreting this interval based on how we interpret confidence intervals, based on what a relative risk is? So these 3 statements, let's start with the first one. We are 95% confident that the risk for contracting polio with the Salk vaccine is between 19.6 and 42.4% of the risk for contracting polio with the placebo injection. So that actually sounds pretty good. I think that is a correct statement. So it's saying that the risk is between these 2 values, that we're 95% confident that risk for one is this much percent the risk from the other, so that makes sense. Now the second statement, we are 95% confident that the incidence rate for polio is this value for the Salk vaccine and this value for the placebo. No. This statement would make sense if I was plugging in those individual absolute risk values, so I could make this correct if I just said the estimated, so let me kind of fix this a little bit. The estimated incidence rate for polio is 0.00016 something, 162, and 0.000571, or 0.0571% for the placebo. So that statement would be correct. But the confidence interval is not telling me what the incidence rates are for each group. It's giving me an interval for what the true relative risk is in comparing those 2 risk rates. The last one here, we are 95% confident that the risk for polio is between 19.6 and 42.4% lower with the Salk vaccine as compared to the placebo injection. No, that is not correct either. So this one's a no. This one's a yes, by the way. And this one is also going to be a no. And that's because we're not 95% confident that the risk is this much lower, but rather that the risk is this percent that of the risk of the other one. So it's kind of that tricky, nuanced phrasing. We don't interpret a relative risk as this percent lower or this percent higher, but it's this percent that of the other. All right, we'll stop there.